Let's take a look at an application of looking at compound interest. This is a topic that's usually covered in college algebra, pre-calc, those types of classes. So hopefully this rings a bell. So let's recall the formula for compound interest. We have A of t is equal to P times 1 plus R over N raised to the NT. So remember, this is for compound interest when we're compounding it some number of times per year. So we had things like this is the amount in the account after T years, P is our principal, our initial investment, R is our interest rate, N is the number of times it's compounded per year, and T is the number of years. So if we look at a very specific example, when I invest $1,000 into an account that pays 8% interest, how much is in there after 1 year? If we look at different values of N, what is taking place? So in these, I get, when N is 1, I get 1,080. N equals 2, I get 1,081.60. N equals 4, I get $1,082.43. N equals 12, you get 1,083. N equals 365, you get $1,083.28. Now, if you notice what's going on with these numbers, is notice that there is a jump, right? As N increases, I get a little bit more money. Not substantially more, but at least a little bit more. So, but notice this jump here is going to be $1.60 when we go from 1 to 2. But then when I go from 2 to 4, all I get is an extra 83 cents. When I jump from 4 to 12, all I get is an extra 57 cents. And if I make this huge jump from 12 to 365, all I'm getting is an extra 28 cents. So it seems like I don't always get a lot more money. It seems to kind of be approaching maybe some type of just a maximum amount that you could really get. So this should start to ring the bell of the idea of limits. Remember, when we saw with limits, if we're approaching some type of number, but maybe we don't have to touch it, but if we get really close to it, we're just going to be maybe leveling off at this point. And so there might be some type of finite limit taking place here. So we'd like to try to study what happens with this limit as N is going to infinity within this expression. So we get this fact. The fact is that the limit is N tends to infinity of 1 plus R over N raised to the N. If I take this limit as N goes to infinity, I'm going to get E to the R. E to the R. Okay. So E appears as a really nice limit. So in particular, the limit is N tends to infinity of 1 plus 1 over N raised to the N is simply E. So we defined E as this arbitrary constant, this 2.71828, but in particular, that is the result of this limit. So you plug in values of N as they get larger and larger, you're going to get closer to 2.71828 and so on. So let's see, how does this relate then to our compound interest formula? So let's take a look at some limits. So if I take the limit as N tends to infinity of A of t, this is going to be the limit as N tends to infinity of P times 1 plus R over N raised to the NT. Now, if you remember things about limits, we have continuous functions, we have constants, we can move things around. So I can pull out this P. I have the limit as N tends to infinity, but I can also now just take this 1 plus R over N raised to the N, take the limit of that, and then raise that to the T power. So I'm going to do that. I'm going to take the limit of 1 plus R over N raised to the N, and all of that to the T power. So this limit right here is equal to E to the R. So I have P times E to the R raised to the T. But if you remember things about rules of exponents, this is just multiply the exponent, and you have P times E to the RT. So this formula here, this A of t, this formula should look familiar when this also looks familiar. This was our compound interest. So this was compound interest, but this was when it was compounded continuously. So when you're compounding this continuously, what we're really saying is that that's the limit as N tends to infinity. So obviously, realistically, yes, you can't really compound this at all possible instances, but intuitively, with the formula, we see exactly now why is the formula that we saw in pre-calc, why is that defined that way? And it's just simply because of limits.